In this video, we will discuss answers of questions related to plotting, control chart, X bar, and also R chart. We found earlier that X bar chart can be drawn based upon the mean of the sample means, or we take X double bar as the estimate of mu, where X double bar is X1 bar plus X2 bar plus etc. plus Xk bar by K. And each of these x1 bar, x2 bar, etc. xk bar represent the mean of the k subgroups. Each subgroup may have 4 to 6 items. So that's about the estimate of mu, and it is done by x double bar. Based upon the estimate of sigma, we have three types of control charts. One is sample mean of the sample standard deviations. Second is the mean of the sample ranges, and the third is mean of the sample variances. In this case, when we consider the control chart X bar with mean of sample standard deviations, we have the control lines X double bar plus A1S bar and X double bar minus A1S bar, where A1 is a constant. We can refer for different subgroup sizes from tables of statistical quality control. And S bar is the mean of sample standard deviations. S1, S2, etc. Sk are the standard deviations of K subgroups or samples. And each S bar I can be calculated using the equation root of 1 by n sigma j is equal to 1 to n xij minus x bar I whole square. The next is based upon range, or we consider range as an unbiased estimate of sigma, and it is x double bar plus a2 r bar and x double bar minus a2 r bar. Here r bar is taken as r1 plus r2 plus etc. rk by k, and here ri, the range of the ith subgroup, is the difference between the greatest and least observations of that subgroup. And here supplement a constant a2, and that is from tables of statistical quality control to make this r bar as an unbiased estimate of sigma. And the third case is based upon sample variances, and here it is given by x double bar plus a root of s square into n by n minus 1 and x double bar minus a root of s square into n by n minus 1. Here s square is the mean of variances of k subgroups, that is s1 square plus s2 square plus etc. sk square by k. And the constant a is supplemented to make the constant s square as an unbiased estimate of sigma. So a value can be considered as 3 by root n, and it can be obtained from tables of statistical quality control. In all other cases, that is in the case of x bar chart with the range or x bar chart with the standard deviation, the constants will also include that value of root n divided by root n and 3. That's how we get the constants from tables of statistical quality control. Now we have the R chart. Here this is LCL equals D3R bar and D4R bar UCL, and both D3 and D4 are obtained from tables of statistical quality control. And next is about the X bar chart and R chart, and based upon the charts drawn in for this X bar and R, we would say the process is under control or out of control if any of the points lie beyond the control lines drawn. We say the process is out of control. If all the points lie within the two control lines UCL and LCL, then the process is under control. With this, we come to the first question. Here we are given control charts for X bar and R are maintained on certain dimensions of a manufactured product measured in millimeter. Then we take 20 samples or subgroups. Each sample or subgroup has 4 items, and we are given certain data, that is sigma is equal to 1 to 20, x bar I is 456.30, and sigma ri is equal to 2.59. We know that here this x bar I represent the mean of each subgroup and Ri represent the range of each subgroup. So we have 20 subgroups. The sum of these 20 subgroups values are given. Now, based upon this data, we have to compute X bar chart and also the R chart. So number of units in a sample is 4 and the number of sample is 20. That is K is equal to 20 and N is equal to 4. So here the value given, and therefore X double bar is 22.815. Therefore the central line is 22.815. Now R bar is obtained by sigma Ri divided by 20, that is 2.59 by 20, 0.1295. Now x bar chart based on range is given by this equation, x double bar plus A2 R bar and x double bar minus A2 R bar, where A2 we can get from tables for sample size 4. For it is 0.73. This is the tables of statistical quality control, and here the A2 value corresponding to the subgroup size 4 is 0.73. So it is here 0.73, and the upper control line is 22.815 into 0.73 into 0.1295, and lower control line is 22.815 minus 0.73 into 0.1295. So we have the simplified values of UCL and LCL, 22.9095 and 22.7205. Next we can calculate the UCL and LCL for R chart. So here these equations are D3 R bar for LCL and for UCL D4 R bar. D3 and D4 you can obtain from tables of quality control, and here for subgroup size 4 D3 is 0 and D4 is 2.28. So we substitute here, so the values are LCL 0, UCL is 0.1295 into 2.28, 0.2953. Now we have drawn the control charts. This is the control chart for X bar and R chart. So we cannot plot the points here because the values of each subgroup are not given. We are only given sum of the means of subgroups and also range of subgroups. And this is the R chart. So based upon this X bar chart with range and R chart, we can identify whether the process is under control or out of control. That's about answer of question number 1. Now next question is with the real data given, and here we have to find out X bar chart with the range and X bar chart with the standard deviation and X bar chart with the variance, and finally the R chart. We are given the data, and here we have 20 subgroups or 20 samples, not 20, 15 only, 50, and in each subgroup we have 5 items, x1, x2, x3, x4, x5 represent the 5 items of each subgroup. So these are the observations. So we calculate all the essential measures here. So the first measure is the total of these observations of each subgroup. So 76 and 24 etc. That is the subgroup total. Now subgroup mean is 15.2, and next is subgroup standard variance is 1.36, subgroup standard deviation is 1.16, and subgroup range is 3. That is the subgroup range means in a subgroup the greatest is 17 and the lowest 40. So its absolute value 3. Likewise, we have the values of all the 15 subgroups or all the 15 samples. Now the first one, the equation for computing all these measures are given here, and central line given by CL. that is equal to x double bar. X double bar is the mean of each subgroup. Its mean is considered, that is x1 bar plus x2 bar etc. plus xk bar by k. You take the total of this column, that is mean x bar I column, and it is 22.7 divided by 227, 22.7, 227 by 50, which is 15.1. Therefore, the central line is 15.1. Now, A2 we can get from tables of statistical quality control for subgroup size 5, that is 0.58. So 0.58 into 3.4, and therefore the upper control line is 15.1 plus 0.58 into 3.4. Lower control line is x double bar minus A2 R bar, that is 15.1 minus 0.58 into 3.4. Thus we have the UCL and LCL with range. Next we calculate the UCL and LCL based upon standard deviation. So we have the standard deviations of each subgroup displayed in the table, and from that we calculate mean of the standard deviations. It is 1.2485. A1 we can obtain from tables of quality control for subgroup size 5. So it is 1.60, and the correct value here I have taken as 1.596 from some other table. So it is 15.1 plus 1.596 into 1.2485, that is the UCL, and LCL is x double bar minus A1 S bar, that is 15.1 minus 1.596 into 1.2485. That's how we have the UCL and LCL corresponding to standard deviation. Next is the control chart of x bar with variance. So here the upper control line, lower control line are given by x double bar plus a root of capital S square into n by n minus 1, and it is x double bar minus a root of capital S square into n by n minus 1, where S square is the mean of the variances of subgroups. So we have already found the variances of the subgroups in the table. So its total is its S square is 2.167, and A we can obtain from tables of statistical quality control, and it is here A equal to 1.342. So I have obtained some other value 1.341. That's from some other table. Anyway, you take it as 1.341. So this is the UCL and LCL. We get it as 17.3071 and 12.8929. Next we draw the control R chart. For R chart we have the UCL D3R bar and LCL D3R bar and UCL D4R bar, and CL is the mean of the ranges, that is R bar. So R bar equal to 3.4, D3 is 0 and D4 is 2.1115. That we can get from the tables of quality control D3 and D4. D3 for subgroup size 5, 0, and D4 subgroup size 5, 2.11. So we have taken here 0 and D4 2.115, and we computed this UCL and LCL. UCL is 7.191 and LCL will be 0 because D3 is 0. Now we plot these values in these control charts. So this is the case of X bar chart with the range. So we see that the lower control line is 13.128 and upper control line is 17.02. 15.1 is the central line. We can note that these two control lines are equidistant from the central line, and all the points lie within these two lines, upper and lower. So for the process is under control. Next is the control chart of X bar with the standard deviation. Here also the lower control line and upper control line, and all the points are lying within the two control lines, therefore the process is under control. So that's the way we plot the points in the control chart and decide whether the process is under control and out of control. I have not drawn the control chart of R bar. A process is under control if both X bar chart and R chart have points lying, all points lying within the control lines. That's about the answers of the questions related to X bar chart and R chart.